The power of stars. If we plot a graph of intensity, or power per square meter, against temperature, we get a relationship something like this. We find that intensity is directly proportional to the temperature to the power 4. What this means is if we were to double the temperature, the intensity would increase 16 times, 2 to the power 4 being 16. We can use this information to help us to find the power of a star. First, we would find the wavelength at which the star emits the maximum intensity of electromagnetic radiation. This we call lambda max. Using Wien's law, which is lambda max times the temperature in Kelvin is equal to 0.0029 meters Kelvin, we can calculate the temperature of the star. Using the previous graph to find the power emitted by every square meter of the star's surface, and if we know the diameter of the star, we can calculate the surface area of a sphere being given by 4 pi r squared. If we then multiply the power per square meter by the surface area, or the number of square meters the star has, we find the total power, what's called the luminosity of the star. Let's run through this example. A star of radius 3 times 10 to the 9 meters is found to emit its maximum intensity of radiation at a wavelength of 600 nanometers. That's 600 times 10 to the minus 9 meters. Calculate the luminosity of the star. Well, first, using Wien's law, lambda max T equals 0.0029 meters Kelvin, rearranging, we get that temperature T in Kelvin is equal to 0.0029 over the wavelength at the maximum intensity. This gives us the figures of 0.0029 over 600 times 10 to the minus 9 meters for the wavelength. Don't forget this must be in SI units of meters. This gives a figure of 4833 Kelvin, about 4800 Kelvin. Then we would have a graph something like this, and if we read up from 4800 Kelvin, we get an intensity of around 3 times 10 to the 7 watts per square meter. The intensity there, 3 times 10 to the 7 watts per square meter. The surface area is given by 4 pi r squared, and we were given the radius here in the question, so we can put that in and get 4 times pi times the radius squared, giving a surface area of a massive 1.13 times 10 to the 20 square meters. The star's power is given by the intensity multiplied by the surface area. So we basically need to multiply this figure by this figure, which I've done here, to give a final power of the star of a massive 3.4 times 10 to the 27 watts.